Hey friends, welcome back to a new Python tutorial. In this case, it's a small little machine learning project, which you can also follow along if you like and try this out yourself. So at the beginning, what I did was I imported a few libraries here. So I used pandas, numpy, matplotlib, and various libraries from scikit-learn. So even if I do not need all the libraries all the time, there are specific basic libraries which I always import, like matplotlib for instance, and so on. In this case, from scikit-learn is important train test split, which means that we're splitting our data into training and testing because we want to train our model on the training data and then of course test our model on the test data, which is a real world data which the model has not seen before, right? That's the idea behind that. Of course, you could also do some kind of cross-validation. If this is an option for you, that would also work. Then for the algorithm here, I'm using the k-nearest neighbors classifier. So we're dealing with a classification problem, and this is just one option. You could also try decision trees if you like, or random forest, or cat boost, or any other kind of classifier. And then I used variance threshold. This simply allows me then to reduce maybe the feature. That's also a feature selection technique just to make sure that the specific features, in this case the columns we have, that they have a certain amount of variance, because if they do not have that and the value is the same in each row, so for each observation, then of course it would not give us any kind of detail, right, which could be helpful for training the model. And then I'm using a pipeline here. So this will follow along later. You'll see what this does. But basically, we can wrap various steps of data preprocessing in this pipeline object, which makes our life easier. I just filter warnings just in case some of them appear, because whenever you deal with different versions of the libraries, then you might get dependency errors, or at least warnings. Errors, it would be a problem, but warnings, and I want to ignore them, so I don't want to plot them. This is why I'm importing this one here. And then I import various, in this case, preprocessing steps like standard scaler, normalizer, min-max scaler, and also a few other ones, right? And finally, I'm using Gridsearch CV because the last thing which I try, which is simply a grid search, just to figure out if I can improve my model further or not. So now we have all the dependencies. Next, we'd like to read the data. And you see here, this specific data set is coming here from the ICS UCI edu. So basically this data set is for free. So you can simply type in this URL and download the data yourself and then follow along if you want. You can read it directly with the read CSV file. So there is actually no need to download it first to your system, but both ways would be possible. The header is none because there is no header in this data, and the separator is simply, in this case, a space. What we see here is then the data set itself. It doesn't tell us too much, but basically what we have here is we have columns, and the various features which are relevant to us actually are the columns from 1 to 7. So these ones, the numerical ones, and the label itself is then in column number 8, this CP or other options we have inside here. The first column, so this one here, is just text and not really helpful. This is why I do not take it into account. Then I simply check here whether we have any kind of missing data, because if that would be the case, we would like to fill this with maybe a mean or something else, right? But we see that there is no missing data in the dataset. Then we select the x and the y values. So x is referring to all our features, and I'm using the pandas ilog method just to, which allows me with a double colon here to select all the rows. And for the columns, I'm starting on column number 1. And exclude the last column. That's what this expression here means. Because what I want here is I want to start here, and I want all those columns up to here. So I want to exclude the last one, and I also don't want to have the first one. That's why I start with 1 to exclude the 0, and end with -1, which means I exclude column number 8. On the other hand, the y value, which is the target itself, is exactly the column number 8, so this one. This is why I can then use the ilog method again, and select all the rows and the last column. And finally, because I want to encode this, I instantiate here a label encoder, and I then fit transform this label encoder to the Y, which simply means that instead of having CP, for instance, I'm having a 0, a 1, and so on for all the different kinds of classes. So if we take us a little look here, let's actually do this. Here, let's say for the classes before we convert them, here for the labels. Or actually I did this already, I guess, but let's execute this again. And then let's say for the Y, we could see in this case, or also refer to the data frame, the original data frame, we could say df dot, in this case, ilog, and then we use all the columns and only the last row. So let's say -1, let's say dot value counts, right? Counts. So let's have a look at that. And this gives us here all the different kinds of classes we have. So we can see also that the data set is a little bit imbalanced actually. So for those classes which are almost not existent, so we can think of something like class weights or any kind of other technique to handle imbalanced data. I did not do this in this case, but you can think about that. For instance, you can use SMOTI, and there are other imbalanced data optimized techniques, right? Okay, so let's get back here. I then use the train test split method to split my data into training and testing data, and I'm using a test size of 20%, which means that the training data set xtrained would be 80% of the original data. Then we instantiate the classifier here, which is KNN. We say it's k-nearest neighbors, and then we fit on the training data, and then we score on the test data just to get an accuracy score. And we see that the accuracy score is almost 87%. So it's not totally bad, but also it could be better, of course. So then we try to use a pipeline, because notice this first example here. When we fit the neighbors classifier here, we did not do any kind of pre-processing for the data. So we used the values, the raw values as they are here, and then we actually did the training. That is why we tried, next step, use a pipeline. The pipeline needs, in this case, specific a name, and then the actual pipeline step you want to apply. So basically it's a tuple with standardizing the data, which in this case I'm referring to the standard scalar. Then I'm using the variance threshold here, and then finally I'm using here the k-nearest neighbor algorithm. And then I fit it on the training data again, and then I score it on the test data to have my comparison, and I can see that now I almost reached to 90%. So quite a good improvement from the standard without any kind of pre-processing here to this optimized using the pipeline, using various steps in here. And finally, the last thing I tried, because I want to see whether I get even better, is then apply specific kind of parameters here for my grid search. So as you can see here, and instead of using only the standard scalar, I told here my grid search for the grid, please try out the standard scalar, the min-max scalar, normalizer, and max absolute scalar, and figure out which of those scaling techniques is the best one to apply. Then I also specified here a threshold. So threshold is actually referring to the next step, so this variance threshold here, and here I can specify various thresholds, which allow me to specify, okay, how much variance has to be in the specific column, and if this threshold is not reached, then the column would be reduced, or in this case discarded, right? So I try various numbers here, and those normally come from, if you want to have some kind of intuition, what kind of numbers should you use, I would always refer to documentation, because there are some standard numbers, and then you can refer to them and apply certain various thresholds around this number. And finally here I'm using the k-nearest neighbors. In this case, by default, I used it here with the default amount of neighbors. I think it's 2 or so, or 3, I'm not sure right now, could be 3, but here then apply various neighbors. So I want to apply k-nearest neighbors with 3 neighbors with 5, 7, 9, and 11. So I test various options here. And this is our grid, which I named here parameters, and this is what we put into the grid search here. So the grid search here refers to the pipe. So again, we're using the pipeline here, all these options, but this time we simply exchange the various steps. So instead of using only the standard scalar, as I said, we apply various scaling techniques, and then we use the variance threshold with various thresholds, and then we apply k-nearest neighbors with various neighbors. And you need to multiply actually the steps, and this is what you get from the grid search. This is why you need to be aware that the grid search itself is very exhausting and very highly computational expensive, because each combination which exists will get applied. And if you have, for instance, 4 combination here, 3 combination here, and then again 3 combination here, then you basically would have 4 times 3 times 3 rounds for evaluating what is the best combination. And this, of course, might explode, so be careful with that and keep this in mind. Okay, so then I specify the grid, referring to the parameters. I have my pipeline. I have CV equal to 2, so I want to cross-validate this 2 times. And then I fit it on the training data with X train and Y train. Here, so here I instantiate it, here I fit it, and then again I score it, and I see that in this case, with these options, I do not get a better score than I had before. So that's actually it for the project. So again, you can try this out yourself if you want. The data is for free. And then what I would encourage you to do is try out maybe different kinds of steps from the ones I have applied here. And especially maybe you want to use a different kind of classifier here. So it doesn't have to be k-nearest neighbor. Think about it. Could be decision tree, random forest, as I said, cat boost, and various other options like knife base. You could also try this one if you want. So it's really up to you. Just try it out. And then maybe write your results into the comment section just to share it with all of us here. Okay. So thanks a lot for watching, for your interest. Hopefully you enjoyed this. If you did, please leave a like and please consider subscribing to the channel, because then I will encourage, of course, to create more videos. So thanks again. Take care and hopefully see you in the next video. Until then, best guys.